Okay, you will have two cable here. Let's say cable Y and cable Z. Okay, so the current flowing here will be current Y and current Z. Both are flowing up. How, when I place these two wires together, right, how would they interact with each other? Let's take a look. So now let's look at current Y first. If you use current Y, okay, you look at the magnetic field lines generated by current Y only. Okay, so you use Maxwell, the thumb represents the current direction. The field line would be coming out, okay, from here on the left side. On the right side of this cable, the field line will be going in. Okay, so now what we are looking at is the red color one is the magnetic field line generated by current Y. Now, when current Z or wire Z is in this field line, okay, in the field line generated by current Y, so what will happen to it? We can use Fleming left hand rule to examine. So now my current is going upwards. Okay, we look at wire Z, so the current is going upwards, and the field line he experienced is actually going inwards. So which means my index finger will be pointing downwards. My middle finger will represent the current will be going upwards. So if you use Fleming left hand rule, I will have a force induced on wire Z, which is towards, okay, to the left. So this will be the force induced on current Z, and this force induced on current Z is due to the magnetic field line of current Y and the flow of current Z in wire Z. Indirectly, we can also apply, if we know that the force induced on wire Z is to the left, by Newton's third law, you will know that the force induced on wire Y will also be on the right side here. Okay, so we will know that these two wires will be attracted towards each other. On the other hand, if you do not want to use Newton's law, okay, what we can do is we can actually repeat the whole thing again, but now the context is on wire Y. So now let's take a look again. Now if we re-examine everything again, but now we take a look at wire Z. Okay, so we look at the magnetic field line on wire Z. If you use the Maxwell rule on wire Z now, you'll find that the field line generated by wire Z, on the left of wire Z, okay, the field line will be coming out of the paper. Okay, then on the right of wire Z, the field line will be going in. Okay, so this can be identified using Maxwell right angle grip rule. Now remember, we are looking at the field line due to wire Z. So now how does wire Y, okay, behave in the presence of the field line by wire Z? Let's take a look. Okay, so current in wire Y is going upwards. The field line he experienced, okay, due to wire Z is actually out of the paper. So if you apply Fleming left hand rule on wire Y, you'll find that the index finger, which is the field line, will be pointing upwards out of the paper, and the current on wire Y will be upwards. Okay, so the middle finger will point up. Remember, the context we are looking here is we are looking at wire Y. So the current will be on wire Y, and the field line will be due to wire Z, which is out of the paper. So the index finger will point out for field line, the middle finger with the current will point upwards. So if you apply your Fleming left hand rule, you will find that the force induced on wire Y will be to the right here. So this is the force induced, okay, on wire Y due to the magnetic field line in wire Z. Okay, so for two cable, okay, the direction in the same direction, the current in the same direction, you'll find that if I put these two wires together, because of what happens between them, the interaction of the field lines between them, you'll find that these two wires will actually be attracted towards each other. On the other hand, if you look at two cables which carry current in opposite direction, for example this, current Y is going upwards, current Z is going downwards. If they are in opposite direction, you will find that these two wires will actually experience a repulsion force. The force induced on them will be repulsion. So these two cables will repel. Wow! And you can actually examine them or identify the direction of the force induced using the same method that I've done before. Okay, so go and try out. Okay.